Hello everyone. So today we are going to solve a LeetCode problem, which is search a 2D matrix. This is very important and asked many times in companies like Google, Microsoft, Amazon, and man companies, and sometimes in service-based companies as well. So today we are going to solve it. Okay. So if we go through the question, so it says you are given an m into n integer matrix with following properties. Each row is sorted. Okay, so each row you can see this row is sorted 1 3 5 7 10 11 16 20. This is in increasing order, right? The first integer of the each row is the greatest, then the last integer of the previous row. So this one is greatest than 7, and you can see 20 is greatest than 23. We have to break down the problem. Okay, that's how we can actually solve, actually learn about leet codes, not just only solve. Our main agenda here is to learn how to tackle such kind of leet code problem. Like we all practices like binary search and all, but if binary search we all practice, but when it is by searching 2D matrix, it's tough. Like it may occur in a uh, surprisingly. So we have to tackle the problem. Okay, so we know how to search in a 1D array. Now we have to do it in 2D array. So there will be a target. If we found the target, then we can return true, or if not, then we can return false, right? So now a simple approach will be using or searching whole the lane, and then the time complexity will be O of big O of m into n, and that is a worst case complexity. We can write it like, first of all we will search every rows, and then the next rows, then the next row. The time complexity will be O of big O of n, m into n, or you can say n square. If n into n, then it will be n square. Now but here they are asking that you must write the solution in big O of log m into n. Okay, so log m into n we can do using binary search. Whenever we saw that we see that the time complexity is talking about log something, we always think about binary search. So uh, how can we search here? Let's see. Like we can say that, okay, one, our start index will be here, and maybe n index will be in this position in 7. Okay, first of all, then we will get compare with the target. Okay, first of all we will take this 7, we will compare with the target. If target is greater, then we can jump to this one. If target is not greater, then we can jump to this one, like 5. Okay, so suppose in the first example they are saying the target is 3. So we will calculate the 3 with 7, and we will see 3 is less than 7. So we will make sure that our columns pointer come to here, comes to here, and then we will again try to uh, compare. And if we will see that 5 is greater than 3, so our pointer will come to 3, and then it will see that, yeah, target is equal to the current sum, the current element. So it will return true. So how to code it? It is very easy. First of all we are going to um, get the number of columns and number of rows we have. Okay, so the number of rows we can say like integer of rows is equal to matrix. Like matrix is the matrix is given, matrix dot size. This will give us the number of rows, and int calls is equal to matrix dot matrix of 0 dot size, right? This will give us the basic size of the matrix. Now we are initializing one in the row, zeroth row. Okay, so int row is equal to 0, and our column will be last one, right? Last one we are taking here. So int col is equal to the number of columns minus 1. So cols minus 1, because it is 0 based indexing. So cols minus 1. Now it's very simple. Just write simple binary search logic while row less than rows, and then call greater than minus 1. We can say we will have the int car, right? Int car will be matrix of rows, matrix of row, sorry, matrix of row, and then call, right? It will be our current element, like 7. In this case it will be 7. First of all, this will be 7, and now we will compare it. If current equal to our target, then we can say that return true. This is only the true case, when we find out the element. Else if the target, suppose, greater greater than the current, then what we should do? We should go to the next row, obviously, and then that's why we should increase our row, so that will row plus plus. Okay, because our column index will stay here only because it is greater. Our row will get increased, so we are doing row plus plus. And else if it is not greater, it is less, then we will do call minus x. Like in this case, it will be in from 7 to get, it will go to 5 only. And if we don't find any the element, a current element which is equivalent to the target, then we should return, then we will break the loop, and then we will return false. Let's see if it's run. It's very easy, and it should run. Yeah, so it is running. And if we submit it, if there is any edge case, let us see. No, so it is submitted. So you can see that it is a like fang base fang level of LeetCode question, but it is very easy one. We need to just know the binary search logic and apply it carefully in our problem. Thank you.